Love the fade, love that. Afternoon, everybody. How's everyone doing today? Awesome, how's the show been for everyone? It's been great, hasn't it? A lot of great tech that's out there, a lot of really interesting sessions going on. A lot of great discussions I've been having as well on the floor. And an interesting part of it has been around kind of cyber and what we're doing on the cyber front. And we are Palo Alto Networks. If those of you who aren't familiar with us, we've been focused on cybersecurity since our inception. We invented this thing called the next generation firewall. It's been around for a while. And since those humble beginnings, we've been advancing our wares into all sorts of great areas where we see organizations such as you struggling with dealing with how cyber is evolving and how threats are evolving. And one of the interesting things that we've been seeing is that you guys, your developers are out there doing all the right things, grabbing the right data sets from the right repositories, locking up their containers, doing all the right dev work to make sure that when they push that application into production, it's locked down, it's doing what it's supposed to do. And all it takes is one remote admin who falls prey to some phishing attack, his credentials are hacked, and off we go. We're screwed. We're going to talk about a way that we can mitigate some of that damage. In fact, we're going to talk a little bit about how we can enhance our remote access security to avoid those types of challenges and to avoid the challenges of our remote and hybrid workforces who are bringing all sorts of crazy new devices onto the network, how we can keep those devices, those users, those accounts secure so they can get access to the data and the applications that we're developing in AWS and other places without disrupting, without causing damage, without siphoning off data. And we're doing that with a technology we call ZTNA. ZTNA stands for Zero Trust Network Access. It's kind of a misnomer. We're not really talking about network access as in the olden days of VPN. We're really talking more about application level access. And that's significant as we talk about how we need to think a little bit differently about our cyber postures and our infrastructures. My name is Don Meyer. I'm part of the product marketing organization at Palo Alto Networks. Been with Palo for about 3 years now, primarily focused on a product called Prisma Access. Prisma Access is an interesting product. It runs on AWS. It is a cloud-delivered security platform that allows us to bring security as close to our remote users as we possibly can and enforce proper policies and do so in an interesting way we're calling ZTNA 2.0. And why we're calling it ZTNA 2.0, we're going to dive into that in just a second. And we hope that this will give you some information that will be useful in terms of what you need to be thinking about as we're evolving our remote access infrastructure and the security capabilities we need to start thinking about in terms of keeping our remote and hybrid workforces secure. This will be somewhat of an interactive session. I want to make sure that there's some time carved out for Q&A at the end. So if you do have questions, please hold them to the end, and we'll have a formal session then. So without further ado, let's jump right in and talk about what's been going on. And those of us who have been around for a while, this is no secret. The pandemic showed us that our workforces can be productive anywhere they work. And as a result of being free to go off and work where they want to, our employees are now demanding hybrid work. I've talked to a lot of organizations who are supporting hybrid work, and it means different things for different organizations. Even with Palo Alto Networks, we're in 3 days a week at the corporate offices. 2 days a week, you can work from wherever you want to. I've even talked to some organizations that support 5 days in the office per month. The rest of the time, the employees are free to be able to work wherever they want to work at. And a lot of times, that's giving them the idea that they can use whatever compute devices they want to use as well. There's a lot of freedom that goes into enabling the hybrid work. But there's a lot of challenges that result from that as well. And we'll get into that in just a second. At the same time, we're seeing that because of the advent and the adoption of cloud, digital transformation is really taking shape and really accelerating. And it's making inroads into all sorts of different ways and processes of which we've been just experimenting with before. Now they're becoming more mainstream. And it has its own set of implications, but it is not slowing down. In fact, it's only accelerating and becoming more and more prevalent as organizations are looking to become a little bit more agile and certainly develop the right capabilities to continue to satisfy the needs of their customers. And on top of that, we have this magical tool called AI. And AI is a really great opportunity, but it's also an interesting threat as well, depending on who you talk to and what they're going to be doing with it. And we'll talk to a little bit about how we can use AI to combat the bad guys who are also using AI. Some interesting opportunities. But one thing that is clear with all of these statistics is that business as usual is no longer business as usual. We're doing different things now, and as a result of that, we need to think a little bit differently about our infrastructure and what infrastructure supports these hybrid workers and all the new apps and new capabilities. It's very clear and was painfully obvious during the pandemic that the old way of doing things, our traditional approaches, just weren't adequate, weren't designed, weren't sufficient enough to allow us to keep ourselves in control. And why is that? Because we always think of remote access from two distinct domains. Number one, the user's domain, right? The remote user, our traditional VPN user. VPN is a great tool. It's been around since the 70s. In fact, IBM was one of the first organizations back in the 70s to be able to develop a technique to allow a user outside of an office to be able to get the same experience or at least access to the same services as if they were inside the office. We called that the virtual private network. It allowed a point-to-point connection to be able to be established from a location to a secure location. Very, very key in terms of allowing us to be able to open up our offices and accommodate for remote staff. Now again, this is in the 1970s. Things had evolved a bit for VPN, but the base premise was that. Point to point, all your security services were at the destination point, so a user would have to tunnel all its traffic to that particular point to get access to the services that they needed. Typically, those services would include security. So VPN, by its very definition, did not necessarily have security capabilities associated with it. But when you terminated at a particular location, those services could be available, and we could then process the security in a way we went. Okay, so that's one aspect of it. The other aspect of it was, how do we enable our branch offices? And typically that was a telco decision, right? We would get MPLS or dedicated lease lines, drop fiber, do whatever we had to do to create a secure connection to that location. But again, point to point. We would send traffic from that location to some other location where the services tended to be originated from. That worked great when everything lived in our data centers. Fast forward to today, fast forward to 2010, a gentleman named John Kindervog had identified that, whoa, wait a second, more and more of our data is now starting to go outside of our data center. More and more applications are being deployed outside of our applications. So much so that in 2019, Gartner also finally woke up to that fact and said, hey, wait a second. The architecture that we're using, or these two architectures that we're using to try and facilitate connectivity and service our employees, they're a little backwards, aren't they? They're servicing things on the inside when more and more stuff is on the outside. Our users and our data are more outside of our networks. So why are we tunneling all this stuff back to a particular location? Wouldn't it make more sense to just let people go directly to the apps? Because after all, that's all they really want. Okay, fine. So long story short of it is that the traditional way of looking at these two networks differently or disparately really kind of Achillesed us. It slowed us down in terms of our ability to be able to adapt and adjust and provide the right types of services and connectivity to these different distinct users. As a result, we saw during the pandemic things breaking, right? VPN, how cumbersome is it to set up new VPN termination devices? How cumbersome is it to manage all that, to scale it all? You have to deploy people at every location. You have to manually and physically touch different boxes and configure things. It's not an easy task. And not only that, because all that traffic has to be brought back to a single location, only to be hairpinned back out to go where it ultimately wants to go, the user experience sucked. So what did our users do? Turn off VPN. Okay, great. Now I got a great experience, but I'm not secure. And all it takes is my kid to come home, play Fortnite on my laptop, then me connect back to my VPN, and whatever was on that device can unleash holy hell on whatever it's destined for. So this architecture, this way of thinking of things doesn't work. Doesn't work today because experience sucks, and there's really no way to scale it to be able to accommodate for what our users need to do. So what do we try to do? As I said before, going direct to app makes a whole lot more sense, right? And our users were doing that anyway, turning off their VPN and going over the internet to be able to get access to the things that they needed. And pretty soon we saw that as users became more hybrid, more and more devices coming onto our network, more and more applications being deployed in the cloud, more SaaS applications being brought into our environment, holy shit, our attack surface is exploding. It's going bananas. It's getting out of control. So what do? Traditionally, being in cybersecurity, we love this. Hey, we got a brand new solution that you need to deploy that's going to fix that one problem for you. Great. Okay, I fixed that problem for those users. Now I got another problem over here with these other users. Got another solution for you. Completely isolated, completely independent, its own set of policies, its own set of configurations, a different UI, but it'll fix that problem for you. Great. And so on and so forth. Pretty soon, we got a hodgepodge of stuff in our security operations centers, all of which are blinking, all of which are generating alerts and logs and telling us, hey, something's going on, none of which are correlating any of that information. It tells really what's going on. We're right back where we started. We're no longer in control. We're not able to see what's really going on, and we're not able to do so in a way that provides a good experience. We got to start asking us questions and really get to the root cause of how we can start to deliver the right security capabilities without introducing additional complexity, without breaking the things that actually work, but do so in a way that is conducive to the user experience. So our users aren't, how shall one say, obligated or feel obligated to circumvent what it is that we're doing. Our users aren't challenged to be able to get access to the things that they need. They just get access to the things that they need to. Don't think about the security capabilities. Don't think about a new process or a new procedure. They just do what they normally do, and the security is already baked in there. That's a lot to think about. And traditionally, it's impossible to think about. However, a category of products came into the marketplace. We started to see the advent of this type of category back in 2010. And that category of products was called Zero Trust, or Zero Trust Network Access, if you will. Zero Trust is an interesting concept. And it is a concept, it's not a product. There is no product that is a Zero Trust product. We have a ZTNA product, a Zero Trust Network Access. It is a product that leverages Zero Trust principles. What are Zero Trust principles? Zero Trust is a construct. It is designed to eliminate trust or to alleviate implied trust. No longer can we trust Don just because I passed a series of credentials, and you can say at that particular point in time, yeah, Don is who he says he is. I'm going to open the door and let Don have carte blanche access to everything. Can't do that anymore. Why? Because the attack surface is too large. Don doesn't mean anything anymore. And the old way that we used to control things was with ports and protocols, source and destination IP addresses. IP addresses don't mean anything anymore either. So the constructs that we used before are a little bit broken. We need to think a little bit differently about how we infuse security into a user requesting access to a thing. How do we do that? And how do we do so in a way that doesn't introduce complexity, doesn't break our security models, and gets us the right outcomes, and allows us to be able to start making sense of this exploding attack surface? Well, as I said, ZTNA came about. The concepts were developed by John Kindervag, who actually used to work with Palo Alto Networks. Kindervag was an analyst at the time. And he had, again, recognized that, hey, wait a minute. The old 5-tuple way that we used to provide policies on our firewalls, source, port, destination, protocols, no longer are effective. One of the first things that broke that was using the web browser as our primary application interface. All of a sudden, instead of traffic going over a particular port to get to a particular application, now all of a sudden, everything's going over port 80, HTTP, or port 443, HTTPS. That's useful because I need to talk internet and I need to talk encrypted, but it's not useful in terms of what that traffic is. There are applications that are embedded into that traffic that I should know about. Maybe there's applications I don't want to have running in my environment. Maybe there are applications I do. But just knowing that port 443 and port 80 are open doesn't help me. I need to get a little bit more context. And Kindervag was talking about that, saying, hey, wait a minute. Context is going to be king. And we need to understand now a lot more about who's asking what, where, and why so we can make the right decisions. Thus was the impetus, or the genesis, if you will, of ZTNA. ZTNA has been around for a little while. At least the constructs have been. It really didn't start taking shape until a couple of years ago when people started feeling the pressure and feeling the pain of VPN. ZTNA 1.0, which we'll call 1.0, the original form of ZTNA, leverages a pretty interesting but a very effective construct of an access broker or some out-of-band service that waits for the infrastructure to tell it, hey, somebody is requesting access to something. That out-of-band broker fields that request, validates the credentials, establishes a connection to whatever application or service that user is requesting, and it does a very interesting thing. It's out of band. As soon as that connection is established, it's Miller time, baby. Time to take a break. It goes away. And trust the infrastructure to be able to take care of that connection. Okay. So far, so good. We've established that now we're vetting users and vetting credentials and not just relying on IP addresses. But we've got some fundamental challenges with this construct or with this model. Number one, I'm only vetting information at one point in time. As we talked about at the beginning of this session, if I'm a remote admin user and I fall victim to some type of phishing attack, or if I go to a drive-by site and my credentials are hijacked, someone could masquerade as Don and log into the system, request access to something on behalf of me. If I'm only vetting it one time, just leveraging multi-factor authentication or whatever it is, and I can pass that along, the network thinks I'm Don. And there's nothing in line with that traffic to validate further if I change my behavior that I am not Don or I am Don. We don't think that's right. We've gone from zero trust to somewhat of a limited trust at a point in time and then implicit trust throughout the duration of that session. We don't think that's the right approach, especially now, considering the prevalency of credential theft. Also, if my device passes muster, yes, I'm running AV, yes, I've got my firewall enabled, yes, I've updated all my latest patches, blah, 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 there could be a bit of code that's embedded into my hard drive, and it's just waiting for that opportunity to wake up and go on off. As soon as my credentials are passed along and we're starting to interface with this application, that's when the malware wakes up and it says, aha, here's an application I can now infect, and away I go. If that access broker is not in line with that traffic, it's not going to see that malware being propagated from my device to the application. We're violating some interesting principles here with regards to zero trust by using this model. ZTNA 1.0 is a good first step. It's a good start. It's starting to take into account additional context, but it doesn't go far enough because it doesn't fully utilize the principle of least privilege. Don, you passed your credentials once, I'm going to come back to you. Don, you're looking weird. You're starting to do things I've never seen you do before. You're logging in at a place I've never seen you log in before. You're utilizing more data than you've ever used before. Something might be wrong. Maybe I want to quarantine that session to determine what's going on. Don, your device, it looked good for a second. Now it doesn't look good. What's going on? Don, that application, it's now trying to talk to China, or it's trying to talk to somewhere else it's never talked to before. What the hell's going on? We need a lot more context, but we also need to continuously validate trust. And we also need to be doing that for every application, not just for the applications in our data center, not just for the applications in AWS, but for any application. And we need to do that consistently for every user anywhere, whether they're a remote user or at a branch office, or whether they're sitting in the corporate offices. And we need to do that consistently across all the different data sets that we have too. Make sure that we're validating and vetting users and inspecting all the traffic. We find that the ZTNA 1.0 approach uses a lot of the right constructs, but just in the wrong way. They believe in things like security by obscurity. You'll hear some of our competitors out there saying that, well, we don't publish IP addresses for any of the applications, so how can someone get to it? Okay. I don't publish my address, but people can find me. I don't necessarily have to rely upon whether my address is published or not. I've got locks on my doors, I got locks on my window, I got cameras all over my house. If someone comes nearby, I can take a look and see what's going on. But default, my doors are locked. Default, my windows are locked. Default, you can't get in unless I expressly allow you into my house. That's what we should be doing. Just because I don't publish an IP address doesn't provide the right level of security. And in fact, it's kind of akin to this, right? That's an old way of thinking about things. Security by obscurity, we've proven time and time again, it's not the right approach. It's not a modern approach. It does not get the right types of results. And thus, we need to think a little bit differently about how we implement these things. ZTNA 1.0 was a good first step, but we need to evolve. We need to get into a different frame of mind if we're going to solve for the challenges that we have of our remote users and now our applications and our data being everywhere. And we feel the right approach is ZTNA 2.0. ZTNA 2.0 overcomes some of those challenges by providing continuous trust verification, as we talked about, not just based on the user credentials, but based on users, devices, and applications. Keeps private apps private. And we can do so. We don't have to publish anything. We'll publish FQDNs only within our own internal environment. Anything that's external is not relevant to what's going on the internal side, and we default to deny, always. And we'll provide continuous security inspection for every session, for every application, for every data set. We think that that's the right approach. And if you break it down into its components, when we are talking about continuous trust verification, as I said before, context is key now. Context allows us to be able to start looking at and asking all the right questions, right? Who, what, where, why. In terms of who, we have these tools called user ID. User ID allows us to be able to pull from IDP stores. We're not an IDP vendor. Whatever IDP store that you use, whatever repository you have for identity stores, we'll integrate with that. We'll pull that information. We'll have it available in this cloud infrastructure so we can vet and validate exactly who the user is. Whatever the schema is that you are affording your users, whether it's two-factor, multi-factor, whatever it is, tokens, you name it, we'll support it. And we'll continuously vet that throughout the entire session. We also use a tool called Device ID. When you use our service, we have a very capable agent that embeds itself into the device. It's almost like a shim. It really doesn't do much of anything. It sits in the background. Uses your device login credentials to establish an always-on connection to the cloud. But it sits and gathers information about that device. And it'll look at the device's encryption status. It'll look at the device's updates and upgrades, look at the services that are running on the device, make sure it's got an AV, all that relevant information that we might need to use to determine whether or not we want this device on our network or not. Get all that information, we build a profile for the users. And that profile will adjust and adapt over time, and it allows us to be able to get very, very granular in terms of how we define who can get into our environment. We start talking about the what. What is very interesting. We use this tool called App ID. App ID allows us to be able to use a variety of different signatures and heuristics to accurately identify applications. Not just the applications now, but also the sub-app functions and any of the API callouts that might be required to run sub-app functions or have sub-IP schemas underneath all that. Why? Why is that relevant? There might be different functions in that application that we don't want to be able to expose. So we want to be able to provide a very granular level of control so that our users are just going and doing the things we want them to do and not inadvertently exposing or taking advantage of exposure that we don't want them to. You can't do that unless you understand applications from a fundamental perspective. Fully qualified domain names, whatever that equivalent would be, it's like a blanket IP address. It gives you just that general domain. It does not give you any sub-app functions. Again, remember when Facebook was the rage, and there was that thing called Farmville, and how many of our stupid users are out there doing Farmville when they should have been working? Well, we couldn't block Facebook as a domain. We couldn't do that because marketing needed to use Facebook. But if we had knowledge of what runs underneath Facebook, what are the different applications associated with that particular domain, then I could get granular in terms of saying, yes, they can go to Facebook and update profiles, but no, they can't go to Farmville or go to any other gaming application. And no, they can't use the social media app and start sharing data. That's the level of granularity you can get when you do ZTNA 2.0 right. Then on top of that, we'll continuously monitor all of these different attributes and make sure, again, we're getting the right outcomes. And we do that irrespective of if the user is remote, at their home office, at a coffee shop, at the airport, at AWS reInvent, at a branch office, or even in the corporate offices. That's part and parcel, core of what it is that we do. And if we can do that right, then we really are delivering on that promise of least privilege. Just that user, that particular configuration, going to just that application, and just being able to do that thing. That dramatically reduces our attack surface and keeps us in control. Cool. On top of that, again, we can make sure that applications are accessible but not overly exposed. As I said before, we have a tool that we can use that will allow us to sit next to the applications, gather information about them, broadcast an FQDN to our internal systems, but externally would just be some benign URL or some other indicator of how to be able to get access to this different application. The infrastructure is intelligent enough to be able to automate that process for us, so we don't even need to think about it. It's embedded into the infrastructure, so I don't need to reprogram anything. I don't need to come up with crazy different schemas. I can just deploy applications, deploy this little tool next to it. It'll supply all the information we need to our infrastructure to be able to ensure that just users who are authorized get access to just those applications. And we do that whether they're in the data center, whether they're deployed at AWS. And at the same time, if you're using a variety of different public applications, same concept, default to deny. We do not allow anything to talk to anything by default. It has to be allowed. That's policy-driven. That's best practices. That's what we should be doing anyway, and it's exactly how we've architected our systems. Then on top of all of that, once we've identified the user, provided that least privileged access to just that application, we're not done. We don't walk away and say, hey, game over. We continuously inspect all that traffic. And we do that with a variety of tools. Again, it's all policy-driven, depending on what it is that use case requires, whether it's compliance mandates, how risky that application is, how risky that user is. We can run all, or you choose whichever the security capabilities are that you need. We have best practices that make it easy for you guys to be able to figure it out. It's all embedded into the system so that whatever the outcome is that you're trying to accomplish, whatever that use case is, we make it easy to be able to accommodate the security wares for that. And we do that everywhere. So the same user, Don, can be logging in at my home office in Tampa, Florida, coming here to Las Vegas at AWS, going to the corporate offices in Santa Clara, going across the seas to Singapore, to our Singapore offices, going to our Moscow offices, and it's the same policy that follows me everywhere. So now the experience is the same. I'm not doing anything different based on where I am geographically. I have the same outcomes. I get the same access. Oh, and by the way, we're running on AWS as well, so it's optimized for performance. So my experience is actually really good, which makes me a lot happier, much more productive, less likely that I'm going to circumvent something and do something stupid. So that's what ZTNA 2.0 is all about. And we feel that, again, based on where we're struggling, based on where we see a lot of the threats coming at us, an upgrade to ZTNA is really, really required to be able to achieve continuous trust, keeping everything private that needs to be private, and providing that continuous security inspection. But as I mentioned before, we're enhancing and continuously enhancing that continuous security inspection, leveraging some very powerful AI tools. So that when we do that, we can then now start to get very, very specific about what it is that we do to give us the upper hand and take the advantage away from our adversaries. We're using a lot of different deep learning algorithms, a lot of different AI and machine learning technologies, and embedding that into our security capabilities to allow them to get smarter. Case in point, remember when we all went home in 2020 and you'd surf online and there'd be all these crazy emails, hey, pandemic, donate some money here, donate some money there. Hey, pandemic, people need your help, blah, 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 blah. The majority of those sites that were popping up were phishing sites. But they were coming up so fast that our URL filters couldn't keep up with it. It needed a signature for every one of those things. We didn't know what the hell these things were because we were getting millions of them every day. However, when we took a look at what was going on, when we took a look at how these sites were being built and being deployed so quickly, we identified some really interesting commonalities across all these different phishing sites. In fact, there were 6 attributes common in every single one of these sites. We taught our machine learning algorithm what to look for. And we pushed it to the wild. And all of a sudden, customers who were calling us up saying, hey, phishing attack, credential attack, stopped calling us up. We were able to stop people from getting access to these different websites in real time because our machine learning algorithms knew now what to look for. What does that mean? It means we're able to stop more things faster because we actually know what we're looking for. And we also know that the tools that are being utilized out there, again, have common attributes. If we know what to look for, we can train our AI algorithms to be able to look for those implicitly and provide the right protections right then and there. And we can do so at global scale. Since we're in AWS, we tap into the resources of AWS, and we can do this in a way that does not impact productivity, does not slow down our other users, it keeps us in control. So we're doing that across our different capabilities. Our advanced threat prevention, that's our IPS engine. We've traditionally utilized IPS as a signature-based tool. You have a specific threat, here's the signature for that threat, you see that threat come in, you have a signature match, boom, we stop that. Threats are coming faster. Threats are being manipulated faster so that they're undetected by signature-based capabilities. We need to augment the signature capabilities, but still do that inline protection. That's where our advanced threat protection capabilities come into play, where we can then, again, start to look at the telltale signs of malware. There are different malware kits that are out in the wild that our adversaries are using. Again, there are some commonalities there that we can identify really, really quickly. And in doing so, stop that malware from at the ingress before it has a chance to even go anywhere it's intending to go. Likewise, if something were to slip by and get into our infrastructure, we have our advanced wildfire service, which is our sandbox solution. In it, we can explode whatever this unknown thing is and figure out what it's going to do. And again, there are ways that malware is designed to evade sandbox detections, right? It sits there and waits for actual human interaction, things that it's programmed to do. Well, having studied all this for the years that we have, we've identified what those things are. How is it programmed? What are the programming codes? What does it look like? So that we can trick it into doing and thinking that there's human interaction going on, so it'll do its thing. It'll try and propagate what it's trying to propagate. Because we can do that and we can utilize this cloud scale, we can provide that protection in real time and prevent malware now from being able to be introduced into our environments. And so on and so forth. Same thing I talked about already with the URL filtering capabilities and DNS security. How many of you guys are using DNS security? One. How many of you guys use DNS? That's better. Do you know our adversaries are using DNS a lot? It is an interesting bastion of kind of unbridled attention, if you will, for our adversaries, but we're not paying much attention to it at all. DNS security is an interesting area that you should be looking at if you're not doing so already, because if you can trick and manipulate DNS, all hell breaks loose. We got a lot more information about that if you come visit us at our booth down on the show floor, but take a look at DNS and what you're doing on the DNS security front, because I guarantee you our adversaries are focused on that. Other things that they're focused on as well are SaaS applications, right? And the data associated with SaaS applications. There's a number of different applications that we're utilizing. And in fact, during the course of the pandemic, we saw that SaaS application utilization went from 10s to 20s to hundreds almost overnight. Does IT understand every one of these applications? Are they all vetted? They're all tolerated, but not a lot of them are understood in terms of their risk factors. We train our algorithms in terms of what to look for, how to be able to respond appropriately, how do we set the right granularity in terms of control for what we want to tolerate, what outcomes we want versus what we want to prevent. And we'll wrap that with a DLP policy that is designed to look for things, including now generative AI. How many of you guys want your developers out there talking to ChatGPT and sharing code, trying to figure out how to create some new line of whatever? Nobody wants that. Yet we're seeing a lot of people doing these things now. Inadvertently, we're seeing a lot of people using this technology, but sharing sensitive data within that technology. Using generative AI is valuable, for sure, but we should do so in a controlled way. And if you do DLP right, you can get that level of granularity and that level of control so that you can keep your users from inadvertently exposing data and inadvertently sharing things outside of the domain. Another interesting area is IoT. More and more devices are coming on, headless devices that aren't authenticating to anything, but they're sharing a lot of information. They're talking to a lot of different cloud services. Some of these things are benign, but a lot of them can be manipulated, and we've seen it time and time and time again. What's interesting, too, is the mix between consumer grade and industrial grade, and how those things are kind of intermingling and commingling. It's good to get a handle on IoT right now before it starts getting out of control. It's good to get a handle on an inventory of what devices are out there and what they're doing, and start to put policies around them, so that when time comes and there's more IoT devices out there than you have users, because eventually that's what's going to happen, we're going to have the policies in place to be able to mitigate whatever it is that we are deploying so we get the right outcomes. And we can also start to look for things like anomaly detections. We can also start to look for anomalous behaviors on these devices. We're training our algorithms what to look for, how to look for it, and how to be more proactive in terms of making the right policy recommendations so that you guys stay in control without having to do a whole lot of manual steps and unnecessary homework. We feel that rounding out your ZTNA capabilities with these types of technologies, augmented by AI, keep you in the driver's seat, really provide the right foundation for transformative change that accommodates the way your people want to do business now, how your customers want to interact with you, how your organization wants to utilize technology. It actually is in alignment with where the business needs to go, as opposed to that afterthought like, oh shit, something's going bad, I'm going to go back and go do some patch, something like that. No, we can actually be a lot more proactive. And we can start to align security to the same business outcomes. Whoa, that's crazy. Because security has never been about enablement, right? Think about it. Security has always been those guys that fold their arms and go, nope, can't. Hey, I want to work remote. Nope, can't. Hey, I want to bring this new application in. Nope, can't. Shit, why? Well, because it's going to break all this other stuff. Well, our developers don't wait. Our employees don't wait anymore. The advent of this crazy tool gave everyone an inflated sense of entitlement. Sheesh, I can bring whatever app I want to on the corporate network now. Ha, I can share my personal data with my corporate data now. Not that I want to. So all of a sudden, we've got this crazy compute device that empowered now legions of our employees to feel like they're their own IT. They can make their own decisions. In some cases, we encourage that. In some cases, we don't. But we can't fight it anymore. Let's get a handle on it. Let's set the right policies so that we can accommodate whatever we need to and ensure that our users are getting exactly the tools they need, where they need them, at a great experience. And talking of experiences, we do these things in the cloud, as I keep saying, at cloud scale, leveraging this fantastic infrastructure called AWS. Not only are we leveraging AWS, we're sitting inside AWS's private data centers, and we have access to private fiber. Why is that relevant? Because we're sitting off of their peering nodes that are an order of magnitude higher than anyone else who's out there in the industry. We can perform at scale fast everywhere that AWS is. That way your users are not impacted when we're running these crazy new algorithms and thwarting these attacks in line. Users stay productive, they stay happy, they're not challenged to do something else. And we stay in control. If we can do this right, we can stop the new threats that are coming out there. And we see 3.5 billion attacks every day. We can deliver and detect more threats more accurately, again, to keep you in the driver's seat. Take the advantage away from our adversaries and give it back to us where it belongs. We need AI to combat AI. We have to. We cannot just throw more resources at it. We can't do it fast enough. AI is a great tool to help us do that. And if we do it right, we can do things like prevent to the tune of 5 billion attacks inline daily. At Palo Alto Networks, we use and eat our own dog food, if you will. We use our own tools, and we have been doing so for quite some time. And we implemented a tool we call XSIAM. And it's a really cool tool that allows us to be able to consolidate all of our logs into a singularity that actually gives us actionable intelligence on what's going on. It correlates all the different information about what we see across the different endpoints, the different enforcement points. And it took us from tens of thousands of alerts to hundreds of alerts down to 4 or 5 perhaps a day that we really need to focus on. When our IT staff is only focused on 4 things a day that are impactful, meaningful, that are going to cause some damage, it means they can solve those things much, much more effectively and go do the other things that help to drive the business forward. That's the power that you can get from these types of tools. That's the outcome that we drive. And as I said before, we're doing this across a global infrastructure, giving high reliability, high availability, the best SLAs in the industry, including SLAs for applications. Again, translated, your users get the best experience. So we can put the best security in place, give users the best experience. They're not going to do something we don't want them to do. They're not going to get impacted. One other interesting thing to think about, too, in terms of experience and performance. There are a lot of other cloud solutions out there, and a lot of them claim to be multi-tenant. And multi-tenancy means different things to different vendors. For us, we believe in true enterprise-class multi-tenancy, where our egress data plane is dedicated per individual customer. Why is that important? Imagine Black Friday, and you're on the same egress IP as a vendor whose sole year is based on Black Friday. And you try and do something that Friday, you can't you can't compete with the volume of traffic there, you're throttled back. Or heaven forbid, they do something stupid and they unleash, inadvertently or otherwise, some malware against some well-known public site, and that IP address gets blocked. Anyone behind that IP address is also blocked. It's going to impact your performance. It'll impact your business. You've got the opportunity for commingling of data. We don't think that's right either, and we feel that if you want optimal performance with optimal security, you've got to do things like isolate your data planes, dedicate them per individual customer. That's what we do. That's the difference between Palo Alto Networks and some of the competitors that are out there. Ultimately, what does this mean? We go back to how we provide the right access to the right application so that we can bring these ZTNA 2.0 capabilities to our environments, giving our users access to just that application they need living in our AWS VPCs. Continuously vetting who they are, what their device is doing, continuously inspecting their traffic, keeping us in control, keeping our hybrid workforces productive, and aligning our security capabilities now finally to ultimately what our business outcomes are. With that, everyone, thank you so much for your time and attention. Hope you enjoyed this. Please enjoy the rest of the show. We'll talk to you all soon.